This video covers how to make a project box from 5052 063-inch aluminum. The box includes top and bottom pieces. A spreadsheet is provided to figure all the dimensions for flat layouts and bends. 2 PDF drawings present the design. Downloads for the spreadsheet are available to run in Libre Calc or Excel. See the links in the description for drawings and all the details. The box shown here will be 6 inches high by 4 inches wide by 2 inches deep with a 1-inch tab. Self-clinching nuts are used to secure the lid. The spreadsheet performs all the calculations required for the 2-piece box design. There are 7 values shown in green at upper right that are user input. These have been filled in to match the example. Calculated values cross-reference to the flat layout drawing dimensions. One drawing shows the bottom and the other drawing shows the top. Together they fully specify the design. We have our piece blanked out at 7.774 inches this way and 6.887 inches this way per the spreadsheet, which does all the calcs and dimensions and bends and notches. So the next step here is we've got to cut these notches, and that cut is going to be 1.887 this way and is going to be 0.944 this way. So we got our notching machine set up to do that. They're symmetric across the center of the piece. Fire up the notching machine. Cut these notches out. There's one. There's 2. So our piece is now notched. We have a box and pan situation here, so there'll be a little bit of stress in this bend. And this tab, when it bends up, will actually overhang the sides of the box, so it's at the full width of the box, which will be 4 inches. So you can do this 2 ways. You can drill a hole here right at the corner, or you can cut a small slot back about 1/16 of an inch, which I'll do here with a hacksaw blade. Come back about 1/16 of an inch on the one side is all you need. And we'll flip the piece over. Same thing on the other side, just cut back. I've tried this both ways with a slot, hacksaw blade, and a hole, and the hacksaw blade thin slot actually yields a nicer corner, which we'll see when we bend this. Okay, we got the notches cut out on our piece, and I did a chamfer, 1/16 inch chamfer on the corners, and then we cut the slot. Here you can probably see that slot right there on both sides to relieve the pressure in the bend. So our first bend here is going to be 0.944 per our spreadsheet. So we'll make that bend first. Fire up the press brake. Cycle the machine. Get that right in there. Okay, there's our first bend. That's the 1-inch tab. So what we got to do now is we got to reset the back gauge so we can get this side and then this side. So we'll do that next. Next we'll bend the sides here. It's a left and a right situation. So if you set up your die and you set up your back gauge properly, you can use one setup to make both of these bends. So let's take care of that. That's one side. That's the other side. So there's our left and right, and there's our pan. Probably hit these bends again to get them squared up a little bit. I'll put a little bit more pressure on the dies. So you hit these again. Hit that side. And we'll hit this side. Okay, that gives us a little bit nicer bend there. So, and you can see the corners here. This will go ahead and bend in a little bit. That's pretty easy to take care of, but this is all lining up pretty well. So this is basically the bottom of the box. It's finished. We blanked out our aluminum for the top of the box. Did a notch. I don't know whether you can see that. We put some scribe lines in here, and these notches are symmetric across this edge of the piece. So we'll go ahead and flip this over, cut that out. We got to line this up now. Bring this down a little bit. We want to line this up. Change the stop. Put that right in there. So we'll cut these last two notches out. The bend reliefs. The most important thing on this is to make sure that the apex of this notch invades the bend center probably around 10 thousandths, just to give you a little bit of extra distance in here when this metal is bent. If you go in too deep, you're going to have a real fat gap, and if you go in too shallow, the metal's going to hit when you bend it. So you want to just leave a graceful clearance on this. But this piece is now ready to be bent first along this side, along this side. So we'll do that next. If you have a nylon vitrified deburring wheel, just soften up the corners a little bit. We want to put some fasteners in the lid so we can hold it to the bottom. The blade on this steel square is 1 inch, so just to make things easy, we'll go in 1 inch on either side. Put a scribe line there, put a scribe line there. We'll come around here, we'll do the same thing. We can flip this over. We'll go in 1 inch. Put a scribe line here, put a scribe line here. And we know our bend here is going to be 1/2 inch on the outside, so we'll take 1/4 inch, 0.250. I don't know if you can see that coming down. 0.250. And we'll just put a scribe line there. Scribe line there. Scribe line there. And a scribe line there. So that locates 4 holes. Let's put some punch marks in there. Okay, so we got 4 holes for fasteners. This will hold the lid down on the bottom. Okay, we'll drill these holes out. 1/8 inch will be fine. 1. 2. 3. 4. before. Got a little tool here for that. Just clean that out. This one needs a little bit more. Okay, so we're in good shape here for the fastener, so we can go ahead and bend this piece. All right, our back gauge is set to 0.444 inches. Fire up the press brake. That's what the spreadsheet called out to bend these sides. Cycle machine. Okay, these bends look pretty good. So the next bends we got to make are going to be here and here, so we got to change the die. Okay, we added this other die to make this interior bend here. We'll get it set up on the back gauge. Adjust our back gauge out. Okay, so there's our lid. See how it fits. Both parts here are completed. The lid and the base. For the dimensions that came off the spreadsheet, so we'll see how these fit together. So there you go. This fit together here pretty well, and then this is our tab. That lined up pretty well. Probably could have eased this up a little bit. There's a, I don't know if you can see that, there's a gap in here. It's not a big deal, but we could have probably made that a little bit smaller by not having the notch invade into the bend center on the side quite as much as it did. It's very critical. Just a little bit really makes this open up a lot. But this fits pretty well. I suppose we probably could have increased the distance of this maybe 5 thousandths or so that it fits together a little bit more easily. But it came out pretty well. I didn't do anything fancy in terms of trying to be extra careful with the accuracy. I just set up the press brake back gauge off the back of the dies as shown in previous videos. I just used my shear. It cuts reasonably square. The length of these pieces and the width I did by eye, so they're unlikely to be 100% accurate, but they're pretty good, so I'm pretty happy with how this fits. So there's your box, 6 inches by 4 inches by 2 inches deep with a 1-inch component tab. So it came out pretty well. We go ahead and drill our fastener holes in here now with 4 holes. So we'll just use these outside holes as registration. Just get marks in there. Take this apart. Okay, so we got our 4 marks in here. This is kind of flimsy on the side, so we'll want to support this before we actually go all the way through the aluminum. We use 632 PEM nuts in here, which call for a 3/16 through hole. So we'll drill that in here. Here's 1. Here's 2. 3, 4. So there's our holes for our PEM nuts. We want to go ahead and drill our clearance holes for 632 screws. Just set up a block for support and open up these holes. 1, 2, 3, 4. So there we have the clearance holes for the 632 screws, and that's done. Last, we'll want to go ahead and press in our 632 PEM nuts. So we can do that right here with the arbor press. Here's 1, 2, 3, 4. So there's our 632 threads for our lid. Let's see how it fits together. We got our PEM nuts pressed in. Got our clearance holes drilled in the lid. We'll put this together. We're going to use 632 screws. Okay, so there it is. There's the finished box with the fastened lid. A couple things we could have done to make this a little bit better. We could have moved these holes down a little bit, so we would have had a little bit more metal on the top side of the PEM fasteners. I'd say move them down maybe 1/16 of an inch, 3/32, somewhere around in there. And we could have closed down this relief here a little bit by pulling that notch back. But otherwise, box fits pretty well. And there's a little bit of inaccuracy here and a little teeny bit here. But overall, considering we did everything by eye, it fits pretty well. So that's your project box.